Hey everybody, it's Cal here from Wise Guys Tutoring, and today our video is about solving one-step algebraic equations. So algebra, needless to say, is a foundational topic that you're going to see in, pretty much all other math topics, and solving the equations is going to be critical for you. So let's start with the one-step equation and see what we can do. So what I mean when I say a one-step equation, I mean it's going to look something like this. X plus 2 equals 5. Or maybe it's x minus 3 equals 7. Maybe you have x times 4. That dot there means multiplication. Equals 8. Or maybe it's x divided by 7 equals 3. So what we're trying to do essentially is we're trying to isolate, which means get these guys alone. Okay? And what we're going to do is remove those guys. The way you do that is by using the inverse operations of these guys here in the middle. Okay, so let's make a little table here. Let's say operations and their inverses. All right, so first we got the operations and their inverses. So let's start with plus. The inverse or opposite of plus is minus, and vice versa, the inverse of minus is plus. Next we have multiplication and division, and as you probably guessed it, they are the inverse of each other. They're the opposite of each other. Now when I say they are the inverse or opposite of each other, what I'm trying to say is that they undo each other. And we're going to use that to move people around and get rid of them and get our x by himself. Okay, so why don't we start with that first one. Let's say we have x plus 2 equals 5. Now I want the x by himself, so I'm trying to get rid of this plus 2. Now we can see on the left there that the opposite or inverse of plus is minus. So what I'm going to do is say minus 2 on there. Now you got to think of the other side as a jealous little brother, and he says, me too, me too, me too. And he wants the exact same thing. You see, whatever you do on the left, you got to do on the right. So plus 2 and minus 2, like I said, they're inverse, they're opposite of each other, so they undo each other. So you scratch those guys right off. And all I have left on the left side is x. And on the right side, I have 5 minus 2. Now with a little bit of arithmetic, boom, we get our answer, which is 3. Now it's not enough to stop here, okay? You always got to check your answer, and there's a very easy way to do that. You just write your original equation, so it's x plus 2 equals 5, right? Then I slip in my answer that I found, so it's 3 instead of x, right? I put 3 plus 2 equals 5, and if these guys equate, then I know I got the right answer. Simple, right? 5 equals 5, boom, you got it. So essentially that's what we're going to be doing for all these equations, and we call it one step because it just takes one step to eliminate, to get the x all alone. It takes one step. So let's try that other one. Okay, let's try x minus 3 equals 7. So if we look there again on the left side, the inverse or opposite of minus is plus. So if I want to get this x all alone, and I'm trying to get rid of the negative 3. By the way, while I'm here, let me emphasize something, okay? This negative 3, this negative belongs to the 3, okay? It's not shared it's not, between them or floating around. It's not part of the equation. It belongs to the guy after him. So in this case, it belongs to the 3, okay? In any case, right now, what I'm trying to do is get rid of that negative 3, and the inverse is plus 3. Now, what does that right side say? He's jealous. He says, me too, me too, me too. So you have to give him the exact same thing, plus 3. Now, on the left here, this negative 3 and plus 3, like we said, they undo each other. And all I have remaining here is x equals, on the right side, I have 7 plus 3. So you guessed it, x equals 10. But that's not enough. You got to check yourself before you wreck yourself, right? So let's do a quick check. I'll put my original equation in here, which is x minus 3 equals 7. Then I'll substitute my value that we found, which is 10. 10 minus 3. Does it actually equal 7? Let's see. Boom, it does. Okay, so everything's good in algebra land. Let's do the other two. We got, maybe I'll work here because I just need a little space. So like I said, this dot is a multiplication symbol. I know usually we're used to seeing it would have been x times 4, and hopefully you can notice that this can get a little bit confusing, especially with different handwriting and different people. So we try to avoid that. You put a dot. In fact, most people will not put a dot. They'll just stick them together. This would be written as 4x equals 8. And when they're stuck together like that, it's as if the dot is there. 4 times x. As you know, multiplication is commutative. That means, it doesn't matter if you say x times 4 or 4 times x. All right. So for the sake of, convention and making it as clean as possible, we're going to just say 4x equals 8. Again, looking over there on the left side at my nice table, the inverse of multiplication is division. So since it's being multiplied by 4, and I'm trying to get this guy x all alone, I have to divide by 4 so that I can undo this 4. Now, right side says, you guessed it, me too, me too, me too. Like a jealous little brother. And by the way, I apologize to any little brothers out there. I'm not saying all of you guys are jealous. I'm just saying in math, that guy is jealous, okay? So he wants the same thing. He wants it divided by 4. Now, as we saw, they are the inverse of each other. So this multiplying 4 and this dividing 4 simply undo each other. And you end up with x on the left side and 8 divided by 4 on the right side, which gives me x equals 2. Ta-da! We're done. Not really. Just a quick check. It doesn't hurt. It'll save you a lot of points, believe me, because you'll catch a lot of mistakes when you do this. So our original equation was 4x equals 8. And if I put my value of 2 in there, is it going to equate? Yes, it does. 8 equals 8. That's great. Boom. There you go. So the last thing we're going to check is that division 1. So x divided by 7 equals 3. And you probably saw there on the left side how I write that. I like to put them, as a denominator. I like to write it as a fraction. It's the exact same thing, right? X over 7, it's a division. It just means x divided by 7. It's just a different way of writing it. So now I have x divided by 7 equals 3. Again, my beautiful table on the left. The inverse of division is multiplication. So if I'm trying to get rid of this dividing 7, what am I going to do? Multiply by 7. The guy on the right is jealous. He says, me too, me too, me too. So he needs the exact same thing. So I multiply him by 7. Now on the left side, that dividing 7 and multiplying 7 totally undo each other, leaving me with x on the left side. And on the right, I have 3 times 7, which hopefully you know your times table, 21. So I do a quick little check because I want to make sure I didn't make any silly mistakes or, lose points for no reason. So x divided by 7 equals 3. I'll substitute my answer, which was 21 divided by 7. Does 3 equal 3? Ta-da! Done. So remember, the name of the game is inverse operations because we're trying to get these x's all alone. And we got to get rid of these guys on the right. And we do that by using the inverse operations of plus, minus, multiply, and divide. Once we use the inverse, what we're doing is removing the unwanted term, whether that be something that's being added or subtracted or multiplied or divided. And remember, we always have that jealous little brother on the right. He's saying, me too, me too, me too. So that whatever you did on the left, you gotta do on the right. So I hope that video made it a little bit easier for you, a little bit clearer. Please like, subscribe to the channel, give me any comments, suggestions, feedback, always welcome. And in the next video, we're going to be checking out something called two-step equation. So make sure to watch that one too. All right, thanks guys.